All right, so our last last chapter we're going to look at is chapter 7. And we'll basically do 3 days of it, or we'll do one section a day. So we'll do 7.2, 7.3, and then 7.4. So we're going to look at logarithms. Okay, so as I said, logarithms aren't really something that is special to trig. It's something you could do in algebra 2. And basically it would be used to solve an equation like that. Okay, it's not a very complex equation, but what makes it a little tricky is you have a variable as an exponent. So it's saying 2 to what power gives you 6? Well, if you try 2 to the second power, how much is that? 4. So let's go up 1. What's 2 to the third power? 8. So 2 to the second power was too small. 2 to the third power is too big. So the answer for x is somewhere between 2 and 3. It's a decimal. How we would figure it out is with a logarithm. Okay? So anytime you have variables in the exponent, that's when you use logarithms. Okay, here's a formula. And this formula is it's a banking formula. Okay, used to calculate how much money you would have if you leave it in a bank account for a certain amount of time. So there's four letters in it. And this is the amount of money. So P is the principal. That's how much money you have in your bank account. R is the interest rate on the account. So the principal, that's the interest rate. N is the number of times that the interest is compounded to your account. Okay, I'll explain what that means. So number of compoundings. And that's usually per year. How many times has it compounded a year? Same with that N. Just same thing again. And T is time. And it's usually measured in years. And that's per year. So if I gave you a problem that said something like, you're going to invest $2,000 in a savings account. Okay, that's your principal. And the savings account is paying, well, most savings accounts now pay very, very little interest. It's usually like 0.1, 0.2%, very low. So not even 1%, like 0.1%. So it's very, very, very low. But let's just make up an example. Some accounts you can make more money, like certain checking accounts. They have requirements to make more money, like you have to use your debit card at least 10 times a month. You have to log in and check your account online at least 3 times. And you have to subscribe to like electronic statements through email. But if you do all those things every month, they'll pay a little bit higher interest. And there's some accounts that I have one that pays 3%, which is incredible. That's like 30 times the amount of interest you could get in a savings account. But if I only use my debit card 9 times that month, then I don't get that. You got to use it at least 10 times, things like that. All right, so let's say you had an interest-bearing account that was paying 3% interest. And let's say they compounded the interest every month. So that means it would be how many times a year? 12. Right? And I use the 12 again right here. And let's say I wanted to know when I'm going to have $2,100. If I just let my money sit in that account, making 3% interest, $2,000 sitting in the account, how long before I make $2,100? Assuming that I don't take any money out of the account and I don't add any additional money. Okay. Notice the letter that I'm solving for, T. It's a variable, and it's in the exponent. If you were going to solve that equation, you would have to use a logarithm. Okay. You've got a little arithmetic. You could 0.03 divided by 12 and then add 1. You could simplify that, and you could divide by 2,000 and bring that to the other side. But the point I just wanted to show you is the variable is in the exponent. Okay. And does anybody know what I mean by that, compounded? I just want to explain that quickly. It's more of a banking thing. It's not really critical for logarithms, but just to understand it. Anybody know what that means? So compounded is when the bank actually puts the interest into your account, when they deposit it. So if you had an account where the interest was compounded monthly, you'd be making interest, every day of the month, but you wouldn't see any of it until they deposit it on your account the last day, all right? So let's say you were going to make like, I don't know, like $5 interest, okay, with that money. You'd be making a little bit of that interest every day, but you wouldn't get it in your account until the 31st. That's when it would be deposited. That's what the compounding is. So some banks compound monthly, some compound daily, meaning you could check your balance every day, and you might see a few pennies in there more, okay, every day. Or it might even, if you don't have enough money, it might be a fraction of a penny. Right? What do you think is better? If banks compound more often or less often? Better for you. More often is better. Because the sooner you get that money into your account, now you're not only making interest on what you had in it, but you're also making interest on the money that the bank gave you, the deposited interest. So the more often they compound, the better. Okay? Any question on that? Kind of gives you more time to make interest. Like if they only compound yearly, then you might make interest all year long, but they don't put it in your account until the last day of December, which means all that year you didn't make any extra interest on the interest because it wasn't in your account yet. Okay, so it's better if they compound it more often. All right, and I might bring up compounding in a little bit, okay, once we talk about something else. So that expression that I had right here, 2 to the x equals 6, okay, or even this other one, 1 plus r over n to the nt, those are called exponential expressions because they had variables in the exponent. Those are both examples of exponential expressions. 2 to the x, 3 to the y. So what we're going to be doing is we're going to be solving exponential equations. And in order to solve an exponential equation, we're going to be changing things between two different forms. There's exponential form, and there's log form. Or there's exponential equations and logarithmic equations. So we'll talk about how do we change between the two. All right, so the first thing I want you to understand is how we write down something that has a logarithm. Does anybody know what letters you write down? Like if you want to do the sine function, you write sin. If you want to do the cosine function, you write cos. What if you want to do the log function? Yeah, you use log. So the first thing to understand is this is a function. It's like sine, it's like cosine, it's like square root. It's a function, and functions have to have a number plugged into them. So if you just told me, or I asked you, what's the log? Log of what? Log of 7, log of 9. You gotta put a number right here that you're taking the log of. Okay? And the number that you put here is called the argument. It's the thing you're taking the log of. So this problem says take the log of 9. Just like this problem, says take the sine of 15 degrees. Okay? This is the argument. It's the thing I'm taking the sine of. Or take the square root of 8. 8 is the argument. It's the thing I'm taking the square root of. All right, so the thing you're taking the log of is the argument. And then usually they put a number down there. Does anybody know what that number is called? It's called the base. And the base can be any number except a negative. Okay, so when we deal with logs, we're not going to deal with negative bases or negative arguments. They'll always be positive. Okay, so that's just some of the terms that come up when you talk about a log. The log is the actual function. We have a base, and we have an argument. Okay, so any questions on that notation? All right. So now, how do we change from an exponential format to a logarithmic format? Okay, how do we change between the two? Okay, so on the left, that's an equation in exponential form. On the right, it's in log form. They mean exactly the same thing. It's just two different ways you can write it. So, there's no arithmetic here to rewrite what's on the left to what's on the right. It's just a matter of moving things around. All right, I'm going to start on the left. I have this a to the y. What's the y? What's it called because of where it's written in that problem? It's the exponent. And what about the a? Because it has an exponent, it's called the base. Yep, good. So when you write something in exponential form, a is the base. When you rewrite it in log form, a is still the base. Okay, so that's the first thing. To write it in log form, I'm going to put the word log, and then the base on the log is going to be the same as the base was on my exponential. Okay. The other thing I want to try to make clear is if that was my line on lined paper, that's how you write it. The word log is right on the line. X is not an exponent. X is right on the line. An exponent would be if I did something like this. 2. Now 2 is the exponent. Okay, so the x is right on the line. The a is actually a subscript. It's the base on the log. It would be written below the line. Okay, on a calculator, they do kind of the same thing. If you type something in on the calculator, it's not quite as obvious, but when I type that in, the 8 is supposed to look like it's a little bit lower than the word log, and the 6 is supposed to look like it's right on the same line. Okay, so just make the base look like it's a little lower. All right, so we know where the base goes. Okay, the next thing is how we can figure out where the y is going to go. It goes by itself on this side. So this goes right there. And the way you can remember that is a logarithm always equals the exponent. A logarithm is an exponent. Okay, so when I just type that in, this number 0.86, that's an exponent. It's an exponent to some problem, okay, whatever this calculation is solving. But anytime you press log, press a button, hit enter, that number is an exponent. Okay? So logarithm always equals whatever the exponent was. All right, and the last thing is the x. And there's only one spot left for it to go. It's the argument. It's the thing that you're going to take the log of. Okay, so I always figure out where the base goes first, and then I know logarithm always goes by itself. I mean, the exponent goes by itself on the other side. And if I can figure out where 2 out of 3 things go, there's only one thing left. All right, other thing. How do you pronounce what's on the right-hand side? You don't say log AX. That's not how you read it. Okay, log AX would mean this. That's not what we have written. The way you pronounce it is log, then say the base. Log base A of X. Or you could also say it's the log of X base A. You could read it that way too. Okay, y equals log base A of X. So if I put up something like this, how would you read that? Yeah, Dylan?
Log base 2 of 7.
Perfect. Log base 2 of 7. Okay, any questions on that? All right, so let's practice a couple problems where we'll change to log form, and then a couple where we change to exponential. I think we'll start out with changing to exponential first. Okay, even if there weren't directions here, and they said change it to the other format, how can you tell which one this is? How can you tell if that's a log or an exponential? It says log. If it says log, yeah, it's a log. If it says something like that, that's an exponential. It has an exponent. That one doesn't. Okay, so first thing I want to do is figure out my base. Okay, so Tom, what's my base here?
3.
3. So when I rewrite it, 3 is going to be the base. And what did I say earlier about logarithms? Logarithms are always used to calculate the exponent, always. Logarithms equal exponents. So what's my exponent here? Y. So we've got the base, we got the exponent. What's the only thing that I haven't used? Well, haven't? X. And where's that going to go? Yeah, on the other side. And that's it. Now, there's nothing you can do with that. Okay, if you knew y was 2, well, then we could have filled that in and done it out. Okay, but if you don't know anything else, that's as far as you can go with it. Okay, 3 to the y equals x. Let's try another one. Okay, so y equals log base 5 of x. Okay, Dakota, what's my base here? 5. Good. So 5 is my base. Alex, what's my exponent?
Y.
Yep. Y is the exponent. Remember, logarithm always equals exponent. Always. And the only thing I haven't used is the x. Again, you don't know why, so there's nothing further you could do with this problem. So we stop there. Okay, any questions on that? Okay, so it's changing to exponential. Let's try it the other way. I want to change something that's in exponential back to log. Okay, if you're going to change it to log form, what's the very first thing you have to write down? Not yet, even before that, we need the word log, we need the function name. Okay, so that's the very first thing. Now you've got spots to fill everything in. You're going to put something here, something here, something there. Let's start with the box that's a little lower. Okay, Catherine, what's going to go in that box? Yeah, the 1.2. The 1.2 is the base. It's the base on my exponent. It's going to stay as the base on my log, 1.2. Josh, what's going to go on the left-hand side?
Would be M.
What do logarithms always equal?
X.
I'm thinking of a word. Logarithms always equal the exponent. Logarithm always equals exponent. So in this case, what would I put? 3. 3 is my exponent. And now we've used 2 out of 3 of them. The only spot left was the argument, and that's where m goes. You don't have to put boxes around it. I just did that to show you kind of the template where stuff goes. Hey, let's try another one of those. E to the b equals 9. Okay, Heather, first step.
Make your formula with the log.
Yeah, write the word log. Okay, that's the function. We're changing it to a log. And you can fill in anything you want in any order. You don't have to do the base first. I usually do. So Taryn, can you tell me anything here I could fill in and where it would go?
E is the base and the next log.
Yep, E is the base. Okay, Maddie, can you tell me what's going to go by itself on the left-hand side?
E.
B. Logarithm always equals the exponent. We've got that. And the last thing I haven't used yet is the what?
9.
Is the 9. And what's the 9 called? It's the argument. It's the thing you're taking the log of. I haven't shown you how you actually type any of this in, but this is one you could type in on the calculator, and you could actually get an answer. You might be looking at it and go, well, how can you do that if you have 2 letters and only 1 number? You can, because E is something special. E isn't just a letter. B is just a normal letter. But E, we'll talk about what that is. Does anybody know what E is? Anybody? It's kind of like pi. You know, in the Greek alphabet, pi is just a letter, but in math it stands for something. Same thing with E. E is an English letter, but in math it stands for a certain number. Okay, I'll show you what it is in a little bit. All right, we'll try one more, kind of switching gears now, going back the other way. So now we're going to get rid of the word log. Alexis, what's my base? E. E is the base. Okay, Eli, what would my exponent be?
-3.
Good, -3. The logarithm always equals the exponent. And Tom, the only thing I haven't used yet? B. And that's it. If they wanted you to find the decimal, that is something you could plug in. Most calculators have the E button somewhere. Mine, I press second and then the division sign. And if I just hit enter, it'll show me what the number E is. It's 2.718. Looks like it keeps repeating, 1828, 1828, but after that, it's not 1828 again. It changes. I don't remember what it is, but it's not 1828. So I could type in E to the -3rd, and if I wanted a decimal for that, it's about 0.05, if I were to round it off. Okay. They just said leave it as an exponent, so you don't have to do it out. Okay, so on your calculator, we'll talk a little bit more about e, but you want to make sure you know how to find e, okay, wherever it is on your calculator. Okay, so this is our first log equation that we're going to solve. And I've picked two numbers that are going to make this easy to do. As of right now, I couldn't just pick any two numbers. Okay, you wouldn't be able to solve it if I picked numbers that didn't come out nice. Eventually you will. Matthias, what kind of equation is that? Log or exponential? It's log. And I want to solve it. What's the only thing we know how to do right now?
Change it to exponential.
Change it to exponential and hope that somehow that works. So Shannon, can you tell me what that would be, the whole thing as an exponential?
2 to the x equals 16.
Yeah, 2 to the x equals 16. Okay, so how, from here, there's really nothing else you have to do algebra-wise. You just have to write down 2 to what power is 16? 4. Now, it didn't look like to me you used a calculator or anything. How come you were able to do that in your head?
2 to the 4 equals 16.
True. Let me phrase my question another way. What is it about the number 16 and its relationship to 2 that makes that easy to do?
Divisible by 2.
Yes, it is divisible by 2, but that wouldn't be as easy of a problem to do,
Right.
even though 20 is divisible by 2. Something else about the number in relation to 2. It is divisible, but yeah.
They're both perfect squares. Least square roots.
Okay, let me do this. This would be a problem that's easy to do, I hope. But 32 is not a perfect square. So another good guess. But what is it about 32 and its relationship to 2, or 16 and its relationship to 2? Here's another one you could do. And 8's not a perfect square either.
X is a decimal, so it comes out to the next number.
Yeah, because 16 is a power of 2. That's what makes it something you can do in your head. So as long as I pick that number to be a power of that number, it works out nice. If it's not, like in this case, well, we're going to have to do something a little different to solve that. Okay, so any questions there on how we got x equals 4? You don't have to copy the other stuff. That was just other examples. Let's try one more of those.
Do you also could change the equation into exponential?
No, not always. It depends. Depends on the problem. Sometimes you'll actually change it to log. You'll do it the other way. But if it's already in log, don't change it to log. That's not going to do much. So if it's usually you change it from one to the other. Okay, what's Ben? What's my base here?
5.
5? How about my exponent?
25, no, x.
X. Remember, logarithm always equals the exponent. And 25 goes on the other side. Okay. Is 25 a power of 5? Yes, then this should be easy to do in our heads without a decimal.
Can we just do it in our heads in the first place?
For this problem? Yeah, I mean, I could do that one in my head. Because I just look and I say to myself, 5 to what power is 25? I don't even do this rewriting. But at first, if you're not familiar with the logs, you might have to do the rewriting. Yeah. So 5 to what power gives you 25?
2.
2. So the answer to the problem up above is 2.
What do you want, like, on the test, do you want us to convert it and solve it?
If it just says solve, you can solve it any way you want. If the problem says rewrite as an exponential equation, then I'm going to be looking that you rewrote it. Yeah. Okay, so any questions on that one? All right. What's a little different about the argument in this one? Yeah?
It's a fraction.
It's a fraction. So let's start rewriting it. 3 is the base. X is the exponent. But this time, the exponential expression equals a fraction. Well, for a second, let's just pretend that it was that problem. What would be the answer if it was 3 to the x equals 27? It would just be 3. That's the answer to that problem. Now, we don't want to get 27. We want 27 flipped. So does anybody remember what kind of number you have to use as an exponent? And it causes it to flip. Josh?
Negative.
A negative. So to solve the problem on the left, basically you're just solving the one on the right, but make the final answer negative. So what would be the answer here? Yeah?
Negative 3.
Negative 3. Anytime you want to get a fraction, 1 over something, your exponent has to be a negative. And you can check it. Just plug in negative 3 for x and see if it works. Try 3 to the negative third power. You get 0.037. And now divide 1 by 27 and see if you get the same thing. And you do. Okay. So it's correct. So any question on that type? So pretty much the same type. Just remember to make x a negative. Now, you might have remembered I said earlier that the base and the argument were never going to be negative. Well, they're not. That's a positive base. That's a positive argument. The answer can come out negative. But the 3 and the 1 over 27, those two things will never be negative. Watch what happens if you try it. Let's try the log of negative 8. What does that mean? The calculator says error, non-real answers. What does that mean? It's imaginary. If you start taking logarithms of negative numbers, you get imaginary answers. Okay? And we're not dealing with imaginaries. Okay? So the argument in the base can be negative, but for us, they will not. All right, we'll talk a little bit more about the letter E. Okay? Pretty much already told you what it was. E is a letter, and it stands for the number 2.71828. How they get that, 2.718? I'm not going to talk too much about how that number comes about. Where does it come from? But it comes from somewhere. And has anybody ever seen a formula that used the letter E in it? I don't know a lot of formulas that use it, but I do know one. And it has to do with banking again. And it's the amount of money equals P times E to the RT. This is another way to calculate interest in a savings account. So I talked before about compounding and how often it happens. Okay, if it happens yearly, you make money all year, and then at the end of the year, the bank puts the money in your account. If it's compounded monthly, you make money all month, and then you get your money for interest a little sooner. You get it at the end of the month. If it's compounded daily, then you make money all day, and the bank deposits 2 cents or whatever the interest is in your account at the end of every day. This formula is what you call continuous compounding. And what that means is that the second you make interest, it's in your account. Like the second. So if you checked your bank account at 1:26 and 5 seconds, and then you checked it again at 1:26 and 6 seconds, you would have a little bit more. You might not see it because it might be like 0.0000001 cents more. But that's how continuous compounding works. The second you make the interest, it's already in your account. You don't wait for it at all. Most banks don't do that. And it's not that it really costs the bank a lot more money. Compounding monthly and compounding continuously, it doesn't actually have that big of a difference. Compounding yearly and compounding like monthly, that's a pretty big difference. But if you're compounding 12 times a year, that's pretty good. I think most banks, they might compound daily, but after monthly, it's not as big of a difference. Okay, that's one of the formulas I know that uses E in the formula. Okay, for us, what will happen is E is going to come up as a base on the log. Well, if E is the base on the log, we have a shorter way to write that. Ln, lowercase l, lowercase n. That's an abbreviation for log base E. Does anybody know what the ln stands for? How about the L? Hopefully we know that one. What do you think the L stands for? Dylan? What?
I have no idea.
Not sure?
No.
The L's not too hard. What are we studying? No, we're not doing trigonometry. It's more algebra 2. Log. The L stands for log. Okay. The N, I wouldn't expect you to know that, but the N stands for natural. So Ln is called natural log, or natural logarithm. All right, so anywhere that you would normally write log base E, okay, and we had that come up today once, right here, you would never see that written in a book. Okay, the way they would write it is like that. They would replace log base E with lowercase l, lowercase n. And that's what I just mentioned. If the base on your log is E, that's called a natural log. What you have to be careful with is when you write this symbol, lowercase l, lowercase n, you're not writing a base. The base is hidden. You have to remember that it's base E. Okay, so that's the only disadvantage of writing it as ln. It hides the base. Okay, and there's a button on most calculators. Okay, if you can find your log button, usually the ln button is right next to it. So my log button is next to the 7. My ln button is right below it. If you have a calculator like this, and all it does is basic arithmetic, you're not going to find log and ln on it. Okay, so you got to have a scientific calculator to have those two buttons, log and ln. Also, notice what happened? I just tried to take the log of 0, and the calculator didn't let me do it. On this calculator, if you try to take log of a negative, it doesn't really explain what's going on. It just says invalid input. What's that mean? The graphing calculator gives you a little more detail. It says non-real answer. So this calculator can't do imaginaries. That's why it says that. All right, so let's take that equation and try to write it in exponential form. Okay, first thing I need here is my base. Alex, what's the base here? E, very good. The base is hidden. Okay, that abbreviation hides it. So you just have to remember the base is E. Josh, what's my exponent going to be?
It'll be E.
Yep. The logarithm, which is what this is. It's a natural logarithm, but it's still a logarithm. The logarithm equals the exponent. And that's the answer. I do not have to type that in on the calculator. They said to rewrite it as an exponential expression, and I did. Okay, so any questions on that one? Okay, so that's kind of the same thing. Instead of an 8, it's a 12. It's almost the same problem. So there's only 2 logs that have special names. One of them I just showed you. If the base is e, it's called a natural log. If the base is 10, it's called a common log. If the base is something other than an e or a 10, like let's say the base is 4, there's no special name. It's just log base 4. Okay. So there's an example of a common log. Log base 10 of 5. That's also a common log. Log 40. What's different about the second example compared to the first one? Yeah, okay.
It's not like below it.
What's not below it?
The 40 isn't like this subscript thing.
Right, the 40 should be right on the line with the word log. That's how I tried to do it. My handwriting looks a little off. 40. So what's different? What's going on? Yeah.
It's assumed that the base of log 40 is 10.
Yeah, they didn't put the base. And that's fine. You don't have to. If you want to do a common log, you don't need to write the base. So like if I go onto the calculator and I just type that in, log of 40, the calculator just assumed that I wanted base 10. If I press ln 40, now the calculator is assuming I want base e. But what if I don't want base 10 and I don't want base e? Okay, what if I want to do this? Log base 3 of 40. Well, 3 is not 10 and it's not e. To type that in, I got to do something a little different. Okay, we're not going to talk about that right now. Okay, so if you have a natural log, what's the base on that? E. What if you have a common log? 10. Perfect. All right, so the last example we're going to look at is going to be solving equations. Okay, we're going to try solving one where the variable is inside the argument. We're going to do one where the variable is the base. And then the last one, we'll do the variable as the exponent. Okay, so we'll try all 3. Okay, so example 7a. Dakota, if you look at that, is that log form or exponential? Log. So what do you think we could do to solve it? Yeah, it's the only thing we know how to do right now. So for this problem, we're going to change to exponential.
How do you know like when you shouldn't change it?
Usually you change it.
Okay.
Anytime you're solving an equation, you're going to have to change it for the type of problems I'm going to give you.
Mhm.
If you had something like this, that you wouldn't change because the variable is already by itself. You just have to understand how to type that in on a calculator. That's all. And I'll show you that tomorrow. Okay, Emily, what's my base in that?
3.
Yep. How about my exponent?
2.
2. Logarithm always equals the exponent, and the only thing I have left is 4x minus 7. That goes on the other side. Now, once you change it from log form to exponential, from here, we just basically use order of operations to solve it. So Norm, what's the first thing you would do here?
Square 3.
Yep, and what would you get? 9. Dylan, next up. Nope, not yet. Add 7. And now my last step, now divide by 4. Okay, so we get x equals 4. Okay, so that's the first type. Variable in the argument. Any questions on that one? Okay, second type. Variable is going to be in the base. Log base x of 64 equals 2. Okay, Cassidy, what's my base? X. How about Heaven? What is my exponent? 2. Okay, and now the only thing I have left to go on the other side, how about Alex? What goes on the other side? 64. Okay, so now I have x squared equals 64. For that one, I can't add, subtract, multiply, or divide to solve it. I have to get rid of squaring. So Selena, how would I undo squaring? Yeah, we take the square root. What times what gives you 64? 8. And what else? 8 times 8, yep, is 64. But there's 2 other numbers you can multiply together that are the same and get the same answer. Negative 8 times negative 8 is also 64. But x was the base. What did I say about the base? Can't be negative. If it is negative, what would you get? What kind of numbers? It'd be imaginary. So we're not dealing with that. So technically there is another answer to the problem, but we get into imaginaries. Okay, so x is 8. All right, last problem. What's different about this example compared to the 2 we just did? This one's totally different. Okay, it's got e in it. What else about the setup of it? Norm? Yep. So I'm kind of looking at the whole thing. It's in exponential form, right? The other 2 problems had the word log and log. This one doesn't. So we have to rewrite it so that it does have the word log. Now we'll start looking at those things individually and put them in the right spot. So somebody already said it earlier, but what is my base here? E is my base. We'll come back to that in a second. What's this going to equal? 2x. And 5 is my argument. Now, what's going on there? That's not normally how we would write it. There's something we can substitute in and make it shorter. ln. What are we going to substitute that for? Log base e. So change that to ln. And now we almost have our answer. We just don't want the 2 next to x. So how do we get rid of the 2? Yeah, just divide by 2. And that's the answer. If they wanted it as a decimal, we could just type it in. So I could type in ln. What do you think I have to be careful about if I type this in? Parentheses. If I don't close my parenthesis, the calculator is going to think I want to do this, which is totally different than what I want to do. All right, so just close your parenthesis and divide by 2. And you get about 0.80 if they wanted a decimal. Okay. Any questions on that? so tomorrow we'll look at some special formulas with logs. And we'll also look at how you can take logs and combine them together. Okay, multiple logs. So that'll be in the video in case you're not here. All right, so homework tonight, it's all evens. Okay, it's on 473. It says 10 to 16, 22 to 28, 34 to 38, and 92 to 98. Okay, just the evens. Okay, so we'll take a look at that tomorrow. Last test for the course will be on Thursday. And I'll probably stay for extra help on Wednesday this week.